Welcome to the Fluke Digital Multimeter Basic Metering Training Program. A multimeter is an indispensable electrical test tool used by a wide variety of industrial and commercial technicians for installation, maintenance, and troubleshooting tasks. Multimeters are also often used by homeowners and hobbyists for personal projects. There are many different models made by many different manufacturers, but the basic features and operation of most of them tend to be similar. This makes it easier to develop basic metering skills that are widely applicable. Many people use multimeters in their daily work without really knowing much about them. Without really understanding multimeter settings and following proper measurement procedures, your readings may be inaccurate, and you may even damage your multimeter, damage the equipment being tested, injure or kill yourself, or cause a hazardous situation for others. Metering skills are not only useful, but keep you safe on the job. Also, metering skills are considered part of being a qualified person, as defined by OSHA and the NEC. A qualified person has extensive training in the skills, knowledge, and hazards of working with electrical equipment. Earning the status of a qualified person will likely help you advance in your job. This is the Basic Metering course. This course provides basic instruction in using a digital multimeter properly in order to produce useful measurements. This course is composed of 26 objectives divided into 6 lessons that are intended to cover the basic aspects of using, choosing, and maintaining a multimeter. The 6 lessons can be followed individually. It is recommended that they be completed in order. Even if you already have a multimeter, this course will cover many features that you may have never used. The additional knowledge and skills you learn here could help you become more efficient and more accurate in your work. And if you've never used a multimeter, this course can introduce you to safe and effective procedures to get you started. Before we begin, there are 2 prerequisites to this course. First, you must have a good understanding of basic electrical circuits. This includes electrical quantities, such as voltage, current, resistance, and capacitance, and their units of measure. You must understand the difference between AC and DC circuits. It's also important to be familiar with how electrical circuits are installed in the real world. For example, when using a multimeter to test a circuit, you should be able to identify the correct wire or terminal screw to test. Second, you must have a good understanding of electrical safety standards, ratings, procedures, and equipment. The importance of electrical safety cannot be emphasized enough. While this course touches on several best practices and features that improve safety, a more comprehensive safety discussion can be found in the Electrical Measurement Safety course. If you are at all unsure of your understanding of the necessary safety information, please review the course first. It's available on the Fluke website free of charge. We want you to be successful in this course and encourage you to study the prerequisite topics before moving forward. Throughout this course, there are a number of short, interactive quizzes to reinforce the concepts being taught. These answers are not recorded, but the results may help you identify areas you may want to spend more time reviewing. However, at the end of the course, there is a scored final exam covering all 26 learned objectives from all 6 lessons. If your score is at least 80% on the final exam, you'll earn a certificate of completion, which can be printed and saved as a record of your participation in this course. All of the course objectives are included on a supplemental page. You may wish to present this certificate and list of objectives to your employer as evidence of basic multimeter training. While the certificate of completion does not prove your qualifications, your employer may take it into consideration as part of your overall training experience. Thank you for selecting this course. You can review your content in any of the lessons at any time. Welcome to the Fluke Digital Multimeter Basic Metering Training Program. Lesson 1. Multimeter Orientation. After completing this lesson, you'll be able to identify what a multimeter is and what it can measure, and correctly configure a multimeter and read its display. Industrial technicians use a wide variety of tools to make measurements. A multimeter is often one of them. Even if some tasks require specialized electrical test tools, a general-purpose multimeter will usually do the trick. Understanding the broad range of capabilities of a multimeter will help you select the best tool for an application. A multimeter is an instrument designed to measure 2 or more electrical quantities. All multimeters measure voltage and resistance, and most will measure current as well. These 3 measurements are the most common, but many multimeters can do much more. They may be able to measure other quantities, like capacitance or temperature, have more sophisticated displays, or include special measurement and recording functions. Early multimeters displayed measurements with a needle on a dial. known as an analog meter. They were designed and used with little concern over damaging a circuit due to their loading impedance. But along with the introduction of microelectronic circuits came the need for digital multimeters. Their high impedance wouldn't load the circuit or components under test. The digital multimeter, also called a DMM, soon became known simply as a multimeter. There are many different multimeter models, and some may look intimidating, but don't be alarmed. They all share common basic functions, and some have more advanced functions that we'll learn about later in this course. For now, you should know that different multimeter models may be required depending on the measurement task. For example, an entry-level maintenance technician may need a multimeter with only basic functions. On the other hand, a technician who troubleshoots or works with control signals may need a more complex instrument. We'll use a common model, the one in the middle, as our example throughout this course. Your multimeter may look a little different, but all of this information should still apply. The first thing to learn about a multimeter is how to configure it for a certain type of measurement. This is done with a rotary function selector switch in the middle of the multimeter. The symbols around the switch represent the measurement functions. Most are internationally accepted symbols, which multimeter manufacturers treat in the same way. However, some symbols may be arranged or combined differently on different multimeters. Most symbols represent the unit abbreviation for what's being measured. For instance, V is for volts, the unit for voltage. Voltage is considered the most common quantity you'll measure, used to detect the presence and level of electrical pressure in the circuit. The multimeter may also have MV for millivolts, typically used with electronics or control signals, or for some multimeter accessories, which we'll talk about later. A is for amperes, or simply amps, the unit for current. Current is typically measured to verify the health of a load. It's relatively common to include an MA for milliamperes and sometimes even a UA for microamperes. These functions are used when measuring very small amounts of current. The graphic symbols above the volt or amp symbols identify if the function is direct or alternating, current or voltage. The parallel, straight, and interrupted lines represent current that's traveling only in one direction, direct current. For alternating current, a curved line is used to represent a simple sine wave. The arrangement and location of functions may vary from meter to meter. Some multimeters are made for measuring very small voltages and currents, which include millivolt and milliamp functions, or have dedicated test functions, resulting in various combinations of letters and symbols around the instrument. Some multimeters combine the AC-DC symbols if the meter is designed to automatically configure the measurement of AC or DC for you. The symbol for ohms is the Greek letter omega, indicating resistance. Resistance measurements tell us about the state of a circuit path or the value of a component. The same switch position typically includes the continuity symbol, which looks like a series of sound waves because the multimeter provides audible feedback when continuity is detected. The beep is especially helpful because you can hear the result without looking at the multimeter display. The measurement of low resistance indicates continuity, which means that current can easily flow through that path. The capacitance and diode test functions are represented by the international symbols for those functions. If you work in electronics, these functions may already be familiar to you. The temperature symbol looks like a little thermometer on this multimeter, but it may appear as a F or C unit symbol on others. And frequency, which is measured in hertz, is there as well. Some symbols on this multimeter are in a different color to differentiate between a primary and secondary function, used to manage the limited space around the switch by placing two measurement functions together. The primary function is the default because it's deemed more common and is shown in white on this instrument. The secondary functions are shown in a contrasting color and are accessed by pressing a secondary function button, usually in the same contrasting color. To return to the primary functions, the secondary function button is pressed again. For example, to measure capacitance, the selector switch is rotated to the position marked by the capacitor symbol. Since the primary default function is the resistance and continuity measurement, simply press the secondary function button to change to capacitance. You can tell you've changed functions because the symbols change on the LCD display. Now you're measuring capacitance. This concludes how to access basic functions with this multimeter. Later in this lesson, we'll learn about manufacturer-specific symbols that access additional specialized measurement functions. You should always refer to the manufacturer's manual for identification and use of any functions you're unfamiliar with. Let's check what you've learned about multimeters and measurement function symbols. A multimeter can measure at least how many electrical quantities? 1, 2, or 3? The most common quantities measured by a multimeter are capacitance, voltage, and resistance, current, voltage, and frequency, or voltage, resistance, and current. Click on the symbol for the resistance function. The digital display shows the numerical value of the measurement being made, including symbols for the units and indicators for active multimeter functions. We'll cover these additional indicators as they come up in the next lessons. A measurement consists of both the numerical value and the symbol identifying the function selected. For example, when measuring AC voltage, the selector switch is set to V with the curved line symbol, and the display shows VAC. Pay careful attention to the units displayed and any added prefix, which is a letter before the unit. The multimeter may add prefixes as needed in order to display the measurement within the number of digits available. For example, when checking an insulator, it's common to measure high resistance in millions of ohms, which are displayed as a capital M with the Greek ohm symbol omega for megohms. A measurement of 2.08 megohms is the same as 2.08 million ohms. There are several other common prefixes you may see on a multimeter display. When you read the measurement, be sure to include the prefix. The decimal point on the display can be shown in many different positions. Together with the unit prefixes, this allows the multimeter to display either very large or very small values. A multimeter typically incorporates the use of several ranges for most types of measurements. The reason for this will become clear soon. But first, we're going to talk about what the ranges are and how we change them. The specific ranges available on a multimeter may vary by function, but they have common characteristics. First, they all begin at 0. And for the high limits, most typically begin with the same initial digit and progress in orders of magnitude. On this multimeter, the voltage ranges are 0 to 0.6, 0 to 6, 0 to 60, 0 to 600, and 0 to 1000. 1000 volts is the highest voltage that this multimeter can measure. Ranges can be selected either automatically or manually. Choosing the most appropriate range, which will provide the best resolution for the measurement automatically, is called auto-ranging. When you rotate the selector switch to choose a measurement function, the multimeter may default to the auto-range or manual range function. For example, if the multimeter is in auto-range and measures 277 volts from a powered circuit, the multimeter will configure its range automatically to select the 0 to 600 volt range and display the measurement as 277.0 volts. The auto and 600 indicators are shown on the display. If you're to measure a very different voltage level, such as 24 volt control circuit, the multimeter would automatically switch to a different range. In this case, the 0 to 60 volt range, and the display shows 24.00 volts. So, how does the multimeter choose the best range? It's the best range that provides the best resolution and still includes the measurement. To explain this further, let's try changing the range manually and see what happens. This multimeter is measuring the 120 volts AC of a power circuit. It's automatically choosing the 0 to 600 volt range. The range button is used to override the auto range. With the first press of the range button, the multimeter enters manual ranging function. Then, each press of the range button scrolls through the possible ranges. If a measurement exceeds the range selected, the letters OL for overload are shown. For example, in the 0 to 6 or 0 to 60 ranges, a multimeter measuring 120 volts displays OL. So, if the range is too small, the multimeter displays OL for overload. But what if the range is too large? If more than one range displays the correct measurement, why is one better than others? Did you notice that changing ranges also changes the number of digits shown? The smallest range, that is not in overload, displays the measurement with the most digits. And generally speaking, the measurement with the most digits shown is the better measurement. This is because it has a higher resolution. Resolution is a measure of how fine a measurement is. A high resolution means that smaller changes can be displayed. For example, these two multimeters are measuring the same circuit. If the voltage changes by tenths of a volt, the one set to the higher resolution will display the change. The other one, set to the lower resolution, may not show the change because it can't display anything smaller than a volt. The rightmost digit shown on the display is the smallest displayable fraction of the measurement. This is the resolution. The value of this digit depends on the location of the decimal point, so resolution depends on the range. For example, in the 0 to 600 volt range, the display shows values from 0.0 volts to 600.0 volts. The rightmost digit represents 0.1 volts or 100 millivolts. In the 0 to 6 volt range, the display shows values from 0.000V to 6.000V. The rightmost digit represents 0.001 volt, or 1 millivolt, 1/1000th of a volt. This high resolution allows you to view very small changes in the measured value. As you can see in the list, the resolution changes with the range. The smaller the measurements, the higher the resolution. How important is resolution? In many applications, resolution's not critical, because tiny variations in the measurement are not that important. However, resolution may be important for certain applications, such as for electronics or control signals. In general, it's best practice to use the auto range feature, allowing the meter to combine the best range with the best resolution for the incoming measurement. Some multimeters include a bar graph as part of the display. This line of LCD elements shows a measurement graphically in relation to the digital numerical reading. For example, a measurement of 200 volts on the 600 volts range will be displayed as a line approximately 1/3 of the way from 0 to the 600 volt mark. So why would this type of display be useful? The bar graph's advantage is that it responds much faster to rapid measurement changes than digits. In most meters, the digital display updates 4 times per second. The bar graph update is 10 times faster, changing up to 40 times per second. In certain situations, you may not need to read the exact value of a changing measurement. You just need to see that it's changing rapidly, and the bar graph will show you that. For example, a bar graph display may be good for visualizing how an analog signal is changing. Notice that the bar graph responds faster than the digits. When taking measurements in poor lighting, a backlighting feature illuminates the display, making the digits and symbols more visible. Some meters have multiple levels of illumination. Pressing the button multiple times cycles the backlight. Let's check what you've learned about reading a multimeter display. What is the multimeter reading on this display? 26.85 volts, 26.85 amps, or 26.85 milliamps? Which is an equivalent value of this measurement? 5.680 ohms, 5,680 ohms, or 5,680,000 ohms? Which is an equivalent value of this measurement? 249.1 volts, 0.2491 volts, or 2,491 volts? Which is the best range for reading this circuit? 0 to 600 millivolts, 0 to 600 volts, or 0 to 1000 volts? Which is the best range for reading this circuit? 0 to 600 millivolts, 0 to 6 volts, or 0 to 60 volts? Which reading has the highest resolution? 5.200 VDC, 24.20 VAC, or 278.6 VAC? The multimeter uses probes attached to the meter's inputs to take various measurements. These test leads and accessories are connected to the multimeter input jacks, which are typically at the bottom of the multimeter. The black test lead is connected to the black input. It's labeled COM for common. The connection of the red test lead depends on the type of measurement you're taking. The inputs are labeled with the symbols of their measurement types. Typically, all measurement functions, except for current, are collected at one input. The test lead connectors are pushed into the input jacks. Current measurements may be taken at one or two different inputs, depending on the meter. If there are two, then the maximum allowable current will be different at each input. If you're not sure what the current is that you're trying to measure, then it's best to use the higher rated input first. If the measurement is below the rating of the other input, then you can move the test lead over to get a higher resolution measurement. It's important that the test lead connections match the measurement type selected with the function selector switch. Some combinations of mismatched settings may damage the multimeter or injure you when the test leads connect with energized conductors. For example, selecting a voltage with the switch but plugging a test lead into current jack is a common mistake. Some multimeters display a warning and/or sound a beep to alert you to a potentially hazardous combination. When measuring current, it flows through the multimeter with little resistance. Flow from an overcurrent condition could damage the multimeter or injure you. So in Fluke meters, the current inputs are fused in order to quickly open such a circuit condition. The maximum allowable current ratings are marked near the inputs. It's important that you observe the markings near the input jacks. Some meters do not have fuses protecting these inputs. When choosing a multimeter for a task, you must be sure that both the CAT rating and the voltage rating meet or exceed the conditions of the measurement and its location. The category and voltage ratings are shown near the inputs. Let's check what you've learned about using the input jacks. When measuring voltage, the red test lead is connected to which jack? When measuring an unknown current, the red test lead is connected to which jack? When measuring voltage, the black test lead is connected to which jack? Which test lead is connected incorrectly? The red test lead or the black test lead? Which test lead is connected incorrectly? The red test lead or the black test lead? Your multimeter may include a protective rubber holster or have overmolding, which protects it from minor drops and impacts. It may also feature test lead holders, a tilt bail, and connections for hanging accessories. The holster can be removed to expose the rear panel. Here the multimeter includes safety information, fuse, and battery replacement information, and agency approvals, such as UL listing information. Let's review the key points from this lesson. Multimeters are available in a variety of models with various features. The basic functions are similar with all of them though. Multimeters use symbols to represent different measurement functions. These symbols are used on the selector switch, digital display, and input jacks. The selector switch is used to choose measurement functions. You can access additional functions by pressing a secondary function button. The display shows a measurement value with the corresponding unit symbol. Pay attention to any prefixes for the unit symbol. The multimeter can use different ranges of numerical values to display a measurement. For maximum resolution, use the smallest range that includes the measurement value. If possible, set the multimeter to auto range. Some multimeter displays include a bar graph. It provides only approximate measurement values but responds quickly to measurement changes, making them easy to see. The black test lead is connected to the black common input. However, the red test lead is connected to different inputs, depending on the measurement. Some combinations of function selection and jack connections can be hazardous if the test leads contact energized conductors. The multimeter must have CAT and voltage ratings equal to or higher than what is required for a measurement task. When you measure current, the input jack ratings must be equal to or higher than the current you're expecting. Welcome to the Fluke Digital Multimeter Basic Metering Training Program. Lesson 2. Around the Dial. After completing this lesson, you'll be able to prepare for and conduct various types of common multimeter measurements. Many measurements are taken on live electrical circuits. Safety is critically important at all times, but that's especially true when dealing with live circuits. If you're not completely comfortable working with live electrical circuits, you should review the Fluke Electrical Measurement Safety Training Program. It's available for viewing on Fluke's website in the training section. Only handle electrical equipment if you have been properly trained and have the appropriate safety equipment. Failure to observe proper safety procedures when dealing with electricity can lead to severe injury or death. Consult a qualified professional if you have any questions regarding electrical safety. The procedure for making a measurement is similar for all functions. First, you must wear the proper PPE for the task. Then, set up the multimeter for the desired measurement function. This involves selecting the desired function using the rotary function selector switch, then plugging the test leads into the correct input jacks. Next, connect or touch the test leads to the appropriate point on the equipment or circuit under test. Best practice is to connect the black lead first and then the red lead. Then read the measurement from the multimeter display. Be sure to note the decimal point and units. Finally, you disconnect the test leads, starting with the red one, followed by the black one. The order that the test leads are touched to or disconnected from an energized circuit is a safety rule. It's best to minimize the time that a multimeter is connected to ungrounded or hot conductors. The red test lead, when touching ungrounded conductors, should be connected last and disconnected first. It's not necessary to do this when measuring de-energized circuits or components, but it's still a good habit to have. It can prove difficult to both hold a multimeter and test leads safely when taking a measurement. Instead, look for a safe location to place the multimeter so your hands are free to hold and concentrate on the leads. Often, it's best to use a magnetic hanger for the meter. This is attached to the back of the multimeter so that it can be temporarily placed on the side of an enclosure or on nearby equipment. Be sure to keep the display visible. The back of a multimeter case may include test lead holders. These allow test leads to be attached in an extended position. In this way, you can hold the multimeter and the black test lead in one hand, leaving the other hand free for the red test lead. Alligator clips provide a safer means of testing hazardous circuits, allowing you to focus on the measurement rather than the connection. Your multimeter's accessories may include an alligator clip attachment for one or both test leads. Do you remember the general measurement procedure? Rearrange the steps in the correct order. Sometimes there's no safe place to set down a multimeter when taking a measurement, and it's hard to hold both the multimeter and the test leads at the same time. Which of these items or methods may be used to safely manage a multimeter and test leads when taking a measurement? The most common type of measurement is for AC voltage. Generally, multimeters are designed to measure voltages of 1000 volts or less. There are many typical levels of AC voltage within this range, from millivolts to 480 volts or more. When troubleshooting, you often need to measure voltage at multiple spots in a circuit. Let's go over the procedure for measuring AC voltage. To configure the multimeter, you first move the selector switch to the AC voltage position. This position is shown with a capital V topped by a curved line representing a sine wave. It's usually the first position on the dial. Then, plug the test leads into the multimeter's input jacks. You plug the black test lead into the common jack and the red test lead into the red input jack marked for voltage. Next, touch the test leads to the circuit. First the black, then the red. The multimeter displays the measurement. Be sure to note the decimal point and units indicated. Finally, you remove the test leads, first the red, then the black. Now it's your turn to take an AC voltage measurement. You're wearing the proper PPE for the task. What's the first step? Use your mouse to move components to their appropriate places or positions. Your multimeter is now set correctly to measure AC voltage. What do you do next? Well done. Now let's move on to the next measurement function. Frequency is defined as the number of times a voltage changes polarity, or states, per second, or the number of cycles that take place per second. The more cycles that take place in 1 second, the higher the frequency reading. This is particularly important for motors, since it directly affects a motor's speed and may be used for some kinds of electronic signaling. The procedure for setting up a multimeter to measure frequency may vary, depending on the function. Some models have a frequency function you can access directly using the function selector switch. Other models may have a button to switch from an AC or DC voltage or current function to a frequency function. This is the case with our example. The procedure for measuring AC frequency begins in the same way as measuring AC voltage. To set up this multimeter to measure AC frequency, the selector switch is moved to the AC voltage position. The test leads are then plugged into the multimeter's input jacks, the black lead into the common jack and the red lead into the red input jack indicated for voltage. Next, the test leads are touched to the circuit. First the black, then the red. The multimeter reads the AC voltage. Then the frequency function button is pressed, and the display changes displaying frequency in hertz. Be sure to note the decimal point and the units. Finally, the test leads are removed, first the red, then the black. Now it's your turn to take an AC frequency measurement. You're wearing the proper PPE for the task. What's the first step? Use your mouse to move components to their appropriate places or positions. Your multimeter is now set correctly to measure AC voltage. What do you do next? Well done. Now let's move on to the next measurement function. DC voltage is usually provided by battery systems, which include those powering portable electronics to large UPSs or uninterruptible power supplies. These systems typically range from a few volts to a few dozen volts. But certain industrial equipment can use DC buses that are hundreds of volts. In the procedure to measure DC voltage, the selector switch is first moved to the DC voltage position. It's indicated with a capital V topped by a straight solid and broken lines. Then the test leads are plugged into the multimeter's input jacks. The black test lead is plugged into the common jack and the red into the red input jack indicated for voltage. Next, the test leads are touched to the battery. Typically, the black test lead is touched to the negative terminal and then the red test lead to the positive terminal. If they're the other way around, that's also acceptable and the number is the same, but simply displayed as a negative. When the measurement shows on the display, be sure to also note the decimal point and the units. Finally, the test leads are removed. Now it's your turn to take a DC voltage measurement. What's the first step? Use your mouse to move components to their appropriate places or positions. Your multimeter is now set correctly to measure DC voltage. What do you do next? Well done. Now let's move on to the next measurement function. DC voltage is sometimes used at low levels for signaling. This can be measured with the DC voltage function. But some multimeters provide a separate function designed for very small DC voltages. This function configures the multimeter for the highest resolution possible, so very small voltages and voltage changes can be accurately measured. Some tests call for making a direct measurement of small voltages. However, the more common application of the DC millivolt function is while using plug-in accessories, most of which output a small DC voltage that corresponds to a temperature, current, pressure, or other quantity. Note that according to the NFPA 70E, voltages below 50 volts don't require PPE. In this procedure for measuring millivolts DC, we'll be using a plug-in temperature accessory. To set up the multimeter to measure millivolts DC, the selector switch is first moved to the millivolts DC voltage position. It's indicated with an MV topped by the DC symbol. Then the accessory is plugged into the multimeter's input jacks. Many accessories are designed so that they can only be inserted into a pair of adjacent jacks, but you should still be careful to use the correct pair. The black connector is plugged into the common jack and the red connector into the red input jack indicated for voltage. The accessory is turned on and set to a temperature scale, if needed. Next, the temperature probe is touched to or attached where needed. The measurement in millivolts changes with the temperature. For example, when 95 millivolts shows on the display, this equates to 95 degrees. Finally, the accessory is removed when measurements are complete. Now it's your turn to take a millivolts DC measurement. What's the first step? Use your mouse to move components to their appropriate places or positions. Your multimeter is now set correctly to measure millivolts DC from the accessory. The scaling factor is 1 millivolt per degree Fahrenheit. The probe end is already in place. What's the temperature reading? Well done. Now let's move on to the next measurement function. A resistance measurement, the next position on the rotary function selector switch, shows how well a circuit path opposes current flow. It's measured in ohms. Conductance is the exact opposite. It's a measurement of how well a circuit path allows current flow, 1 over the resistance value. It's measured in Siemens, or actually tiny fractions of a Siemens called nanosiemens. Resistance and conductance provide similar information, but one or the other may be easier to use with very large or very small numbers. For example, if something has a high resistance in hundreds of megohms, it may be easier to view that measurement as a few nanosiemens instead. All multimeters measure resistance, but not all meters measure conductance. If your meter offers this function, it's typically accessed at the same selector switch position as resistance. A secondary function or range button is often used to change from resistance to conductance. You may need to refer to your multimeter's manual for specific instructions. Resistance and conductance are used for several types of tests. They're used to measure very high resistances in insulation meant to prevent current flow, like the insulation on motor windings. Periodic resistance testing can show if insulation is breaking down, indicated by falling resistance over time. Resistance measurements are also taken on components meant to have some resistance, like resistive heating elements, to check their condition. Finally, resistance measurements are taken on components intended to have very low resistance, like switch contacts and conductor connections and splices, to find spots that cause voltage drops and excessive heat. First, any component being tested for resistance or conductance must be de-energized and removed from the circuit. You want to do this for safety's sake and also because connections to the circuit can and will often affect the resistance measurement. To configure a multimeter to measure resistance, the function selector switch is moved to the resistance position. This is indicated by the omega symbol. Test leads are then inserted into the multimeter's input jacks, the black test lead into the common jack, and the red test lead into the red input jack indicated for resistance. Next, the test leads are touched to the isolated component under test. When testing disconnected and unpowered components, the multimeter provides the power so the order of the test leads doesn't matter. When the measurement shows on the display, be sure to note the decimal point and units. To measure conductance with this multimeter, the range button is pressed. With each press, the multimeter cycles through the available manual ranges for resistance until the units change to NS for nanosiemens. This range is intended for very low conductance, less than about 16 nanosiemens. If it's greater than that, the display will show OL for the overload. Otherwise, the conductance measurement shows on the display. Finally, the test leads are removed. Now it's your turn to take resistance and conductance measurements. What's the first step? Use your mouse to move the components to the appropriate places or positions. Your multimeter is now set correctly to measure resistance. What do you do next? You're now measuring resistance. What's the reading? Correct. Now we're going to measure conductance, but we need a much higher resistance to do that. About 20 megaohms should do it. We can move one of the test leads to the outer casing of the heating element, which should be insulated from the electrical connections. The multimeter now displays conductance. What's the reading? Well done. Now let's move on to the next measurement function. Continuity is the condition of having a very low resistance connection. The only difference between measuring resistance and testing continuity is that a multimeter with an audible function will beep if resistance is considered low enough for continuity. The beep is helpful because it allows you to conduct continuity tests quickly without the need to view the display. Multimeter manufacturers may each define the resistance level that triggers continuity differently. But for our multimeter, a resistance less than about 30 ohms triggers the beeper for continuity if the audible feature is selected. Your meter may default to beeping for continuity, or you may have to press a button to turn the feature on. A continuity symbol looks like a series of sound waves. Continuity is used to test a circuit for a low resistance path and ensure that connections and splices are good. Also, continuity is used to check switches to see if they're working properly or to identify the terminals. While the multimeter is connected to two terminals, the switch is operated back and forth to determine which position has continuity. When measuring resistance, any component being tested for continuity must be de-energized and removed from the circuit. To configure the multimeter to test continuity, the selector switch is set to the resistance function, indicated by an omega symbol. Then the test leads are plugged into the multimeter's input jacks. The black test lead is plugged into the common jack and the red into the red input jack indicated for resistance. Then the continuity button is pressed to turn on the beep indicator. Next, the test leads are touched or attached to the component under test. Similar to measuring resistance, the order of the test leads doesn't matter. The terminals across the switch may not have continuity at first, but as a switch is toggled, continuity should be indicated for one of the positions. Finally, the test leads are removed. Now it's your turn to test for continuity. What's the first step? Use your mouse to move the components to the appropriate places or positions. Your multimeter is now set correctly to measure resistance. What do you do next? The multimeter is now testing for continuity. Try toggling the switch by clicking on it and see what happens. Which switch position has continuity? Well done. Now let's move on to the next measurement function. A diode is an electrical component that allows current to pass in only one direction. Components with similar functions include transistors and SCRs, silicon-controlled rectifiers. In one direction, they have a very high resistance, but in the other direction, they have a very low resistance. The direction of a diode can be determined by its marking. A large diode may have a diode symbol on it. Most diodes, however, are too small for this kind of marking. They use a black or white band around the diode to mark the negative end. Diodes can be damaged in ways that you can't see, but can be tested with a suitable multimeter. The meter's diode test function sends a small current through the component. Then the meter measures the resulting voltage drop. In the low resistance or forward bias direction, there should be a low voltage drop, typically around 0.5 to 0.8 volts. Then the test leads are reversed. In this reverse bias direction, the multimeter should read OL, overload, meaning that the resistance is very high. However, an overload reading for the forward bias direction indicates that the diode is open. A reading of 0 volts in either direction indicates that the diode is shorted. In either case, the diode is damaged and must be replaced. Now let's review the procedure for testing a diode with your multimeter. First, the circuit must be de-energized prior to removing the diode from the circuit. To set a multimeter to test a diode, the function selector switch is moved to the diode test position. The test leads are then plugged into the multimeter's input jacks. The black test lead is plugged into the common jack and the red test lead into the red input jack indicated for diode test. Next, the test leads are touched to the diode. The order of connecting the test leads doesn't matter, but their position on the diode does. For the forward bias test, the positive end of the diode is touched with the red test lead and the negative end is touched with the black test lead. The multimeter displays the result. Then reverse the positions of the test leads for a reverse bias test. The multimeter displays the second result. Finally, the test leads are removed. Now it's your turn to test a diode. What's the first step? Use your mouse to click on a part of the multimeter or diode to perform each task correctly. Your multimeter is now set to test a diode. What do you do next? The multimeter is now testing the diode in forward bias. Now reverse the test leads at the diode and see what happens. Capacitance is the ability to store an electric charge. Capacitors of varying capacitance and type are used in electronic circuits and large power circuits to condition voltage signals and supplies. Capacitors are made in many shapes and sizes for different applications. There are also polarized and non-polarized types. Capacitance is measured in farads, but most capacitors are sized in fractions of a farad called microfarads and nanofarads. Measuring capacitance